Bonjour, Kinamagianine, Ireland, Indigenicas, and welcome to today's math lesson. Our lesson today, Chapter 2, Lesson 4 from your My Math Volume 1 Student Edition, Multiplication Patterns. All right, let's begin our lesson here on our essential question. What strategies can be used to multiply whole numbers? That is the focus of this lesson and this entire chapter. By the time we're done, you should have multiple strategies to multiply numbers in different circumstances. We're going to skip ahead to this quick check right here. I'm going to need my annotation tools right off the bat. Writing this as an exponent. There are two ways I'm going to ask you to write it. One is by typing it. And when we do this, we need first our base. What number do I keep repeating? If you said 6, good. And then if you're typing in an answer like in Google Forms, to show me an exponent, I want to use the Shift 6, which is that uppercase caret. And how many 6s were there? 4. I'm going to do the same thing here, and then I'll show you a handwritten way. What's my base number? What number do I keep multiplying? 8. That's my exponent. 3. There are 3 8s. Another way to do it is you write your base number. If you're doing this handheld way, this is the way I want you to do it. And then you just write 6 to the 4th power. The 4 should be up higher. Even if it's a little higher, it's all right. But it should not look like a 64. Over here, I have an 8. Right, each power is a product of the same factor. This was a question in your homework. And let me model, I'm going to use my text box. So what I do here is I take my base number, that's the number I keep multiplying, and then I use my exponent here to tell me how many of those are there going to be. So I have 5 times 5 times 5, and if I'm going to find the value, that's another way of saying equals. Well, 5 times 5 is 25, times another 5 is 125. There may be certain instances where you will benefit from checking your work on a calculator with some of these bigger numbers. Let's put another one. Make this a little longer for us. What's my base number? 3. So that's the number I keep multiplying. And there are going to be 6 of them. 3, 4, 5, 6. Correct? Yep. And now let's go ahead and put an equal sign because I need to find the value. It gets tougher. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. Times another 3 is 729. Yes, I was working on that in my head. Didn't pull out a calculator, but let's be honest, it's not an easy problem. If you needed a calculator, they're completely justifiable. All right, there are 1,024 bytes in a kilobyte. Write this number as a power of 2. So I'm going to use my thing here again. And obviously, as a power of 2, I know that it's going to be 2. And then let's figure it out. We're going to count here. 2, 4, 8, 16, 32, 64. That's the 6 rounds. And if you think about college basketball tournament, there's 6 rounds and 64 teams. Now we're going to go 128, 256, 512, and finally 1024. So it is 2 to the 10th power. So I have to multiply 2 10 times, 2 times 2 times 2, so forth, till get to 10 of those to get to 1,024 bytes in a kilobyte. I'll clear the drawings and let's move ahead in our lesson. Our lesson today is to describe the relationship between patterns and multiples of 10. Right now, you would approach these problems as, well, 7 times 10. We got 10, 20, 30, 40. But there's an easier way, and that's what we're going to focus on today. So I'm going to get my annotation tool again here. And to do these, let's find the solution. What's 7 times 10? Well, you know that 10 groups of 7 or 7 groups of 10 is going to be a 70. Let's go to the next one. 7 times 100. 700's 700. What do we notice about these two numbers? One, that they both begin with a 7, and they both have zeros. But how many zeros? We multiplied by 10, and we had 1 0. We multiplied by 100, we had 2 zeros. Keep that in your mind. There's going to be more to that. Let's clear the drawings. Now let's kind of go to here. 10 squared, 10 times 10 is 100. So what number goes into, how many times does 100 go into 300? Well, 3 times. Go down here. 10 times 10 is 100 times 10 is 1,000. How many times does 1,000 go into 3,000? 3. Now we have 10 to the fourth. And we know that 10 to the third was 1,000. So 10 times 1,000 is 10,000. 10,000 goes into 30,000 3 times. By now, you should be starting to see a pattern. The number of zeros, when you're multiplying by tens or by a factor of 10, is determined by the number of zeros right here. Notice the exponent. There's the exponent's 2, there's 2 zeros. The exponent's 3, there's 3 zeros. The exponent's 4, there's 4 zeros. And then we just multiplied, oh, I don't want that. I want the, let's get this piece here. Notice that there's a 3 times 1 is 3. That's how we get that 3. And then we just count the zeros and add them on. And once you have that down as a strategy, it's really fast. So even if I was going 24 times a million, I could go 24 times 1, and then I know there are going to be 6 zeros. So I'd write 24, comma, 0, 0, 0, comma, 0, 0, 0. Knowledge of place value also helps here too. So let's go ahead and clear the drawings. You see the answer key there. And extend. Let's see, what do we know as far as the answers here? Text here. 7 times 1 is 7. And that this 3 tells me there should be 3 zeros. 1,000. Now I have 7 times 1,000. 7 times 1 is 7. There are 3 zeros, 1, 2, and 3. So I'll put a comma, and 7,000. Now this one gets a little tougher. 7 times 10 is 70. 70 times 10 is 700. 700 times 10 is 7,000. You should now be seeing a pattern. All of these have the same product, which means answer to a multiplication problem. This told me there were going to be 3 zeros. I counted the 3 zeros. And again, I counted the 3 zeros. And because we were multiplying by 10 or 100 or 1,000, I know that I was just using my identity property and going 7 times 1 and then counting the zeros and adding it. Very important that you have the ability to do that. It'll make things so much faster. All right, let's clear the drawings and move forward. This is going to be example basic in your Math in My World page. We'll go ahead and open that up in our packet for this lesson. And it says Pet Paws is ordering more goldfish to sell at their store. Each goldfish costs $2. Use the table to determine the cost of 10, 100, and 1,000 goldfish. Display the pattern in the number of zeros when multiplying the cost $2 by powers of 10. So I'm going to use my annotation tool here. Let's select the text. 2 times 1 is 2. What's 2 times 10? If you said 20, good. We're going to keep moving down this column here. 2 times 100. Well, 100, 200, 200. 2 times 1,000. 1,000, 2,000. You see there's a pattern. Times 10, there's 1 0. There's 1 0 here. There are 2 zeros. There are 2 zeros here. 3 zeros, 3 zeros here. And then we multiplied the non-zero digits. 2 times 1 and add the zeros. 2 times 1, add the zeros. 2 times 1, add the zeros. 2 times 1, no zeros, just test to me here. So let's go the number of zeros in the product. That means answer. There's 1 there, and you saw that. There's 2. And there's 3. Now, if you start noticing, there's the pattern. It's straight down. If I was going by 10,000, it'd be 4 zeros. If I was going 100,000, 5 zeros. If I was going by a million, 6 zeros. And that coincidentally happens to be how many zeros are in those numbers if you put them on the place value chart. So go ahead and fill that in as you go. And we'll move forward. Anytime that you need to fill something in and I move a little too fast on this video, use the pause feature. That will help you. And if something didn't seem clear and you want to listen again, back it up. This is the great part about the asynchronous part, is that you can rewind and go forward anytime you want. So I'm going to go ahead and clear. Close that, and let's go to the next screen. You always see the answers a little more neatly written. You might notice the pattern shape, the pyramid shape to this pattern. So let's continue on. So the number of zeros in the product increases when the power of 10 increases. Each successive power of 10 adds how many zeros? And if you remember that there was 1, 2, 3, well, each one we're adding 1 0 to the product. If you're multiplying by 10, you just added a 0. If you multiplied by 100, you added 2 zeros. Multiplied by 1,000, 3 zeros. And each of those are powers of tens. 10, 100, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million, 1 billion, 10 billion, 100 billion, 1 trillion, 10 trillion, 100 trillion. You might see a pattern even in those words. How many zeros are in the product of 7 and 100? Well, let's count the zeros. How many zeros are there? You said 2. Good. There are 2 zeros. How many zeros are in the product of 21 and 10? Let's count them. 1. So then I would 1. And the next one, how many zeros are in the product of 12 and 1,000? 1, 2, 3. There we go. And it doesn't matter if the 0 was over here, we would still count it. We count all the zeros because in essence, if this had been 120, that's 12 times 10. And using the commutative property of multiplication, we can move things around. So go ahead and fill this in if you haven't already. You probably already have this chart on your page filled in. Go ahead and clear now. Let's move on. You see the charts filled in. Example niche 2 in our language, dos, zwei. All right, so find 13 times 10 squared mentally. When it says that, we want you to do it in your head. I don't want you to use a calculator. I don't want you to use paper and pencil. I want you to use your dome. So write 10 squared without exponents. 13 times 10 squared. Well, I guess I need to know what is 10 squared. 10 times 10 is 100. Count the number of zeros in the power of 10. By the way, this 2 here told me how many zeros. If this had been 17, I'd know there's 17 zeros. All right, so count the number of zeros in the power of 10. There are 2 zeros. Compare the number of zeros to the exponent of 10 squared. They are the same. Write the zeros to the right of 13. So if I was multiplying, I now multiplied the non-zero digits. 13 times 1. As you know, it's 13. And then I will put in 0 and 0. So the product is 1,300. Yeah, we're counting zeros and adding them to the end. Once you have this pattern, it'll go quickly for you. Once you have this written in, if you need to pause the video to do such, feel free. For those of you in here, give you about another few seconds to have these in. Always make sure you're writing these as you go and as I present them. All right, let's clear the drawings. Close that. We'll move on to the answer key here. The next example, number 3. Find 40 times 7,000 mentally. Again, we do not want to use a calculator or a paper and pencil. So our first step is to write the text here, the basic multiplication fact. So what times 4 is 28? And if you already know it's 4 times 7, sure. 8. Let's count. Now we count the zeros. So this was our non-zero digits. There's 1 0 here, and over here, 3 more. Write the zeros to the right of the product from step 1. So we had 1 and 3 is 4 zeros. And I am aware that I'm going to copy over this. That's easier than trying to line up. So the product is 280,000. Go ahead and write that in. So 10 squared is what? Let's go back to my annotation tool. Let's work through this. How many zeros are in 10 squared? What does that exponent tell you? Right, that there's 2. Total number of zeros, 2. So 8 times 1 is 8, and there are 2 zeros. And there we go. All right, I'm going to have you practice a few. We're on the independent practice portion now. Remember your steps are you multiply the non-zero digits and then add your zeros. What I'll ask you to do is to, once I'm done speaking, pause the video, answer these questions, unpause the video, and come back. You may pause the video now. Welcome back. Let's see the answer key. 13 times 1 is 13, and there were 3 zeros, 13,000. 37 times 1 is 37. This tells me there were 2 zeros. There we go. 30,700. 9,000 times 3. 9 times 3 is 27. 3 zeros, 27,000. 37 times 10 squared, or 10 to the second power. 37 times, oops, sorry, I did that one. 37 times 1 was 37, 2 zeros. And next one, 8 times 10 cubed, or 10 to the third. 8 times 1 is 8. And that tells me there are 3 zeros, so 8,000. Find the missing number. Now you could do this by dividing the number here by the non-zero digit here. So 7 divided by 1. How many times does 1 go into 7? And you know that was 7. And then you find the value. So 7 times, no, just put the 7 there. So go ahead and see if you can find these missing numbers. And I'll see you on the other side. You may pause the video now. Welcome back. Let's see how you did. We talked about that 7. The number 10. 12 divided by 3 was 4. But we also had to get rid of 2 zeros. So we took these 2 out and these 2 out, and that left me with 2 more zeros, so 400. And that's one we really didn't get a chance to visualize during the class period. Because we know that this zero, the number of zeros here, has to equal the number of zeros here and here. And I knew there was 2 here, but there's 4 there, so I had to get 2 zeros from this number. 12 divided by 3 is 4, 2 zeros, 400. All right, 9 divided by 1 is 9. I take out the 2 zeros, just 9. 2 zeros here, 44 divided by 1 is 44, and we're good to go. Remember, if you're stuck, please make sure that you either send me a message, and I can always live Zoom with you, or you can join us for our live stream when available. All right, each box contains 10 squared pencils. The school store has 15 boxes of pencils. How many pencils does the school store have? So now what we have to do is multiply the 15 boxes times 10 squared. So go ahead and do that, and I'll see you on the other side. Let me pause the video now. Welcome back. Let's see what you got. 15 and 2 zeros, 1,500 pencils. Notice the label. That's a good thing to remember. He runs an average of 15 minutes each day. She has a goal of running 10 squared minutes in 7 days. Will she complete her running goal? Well, let's do 15 times 7. Is that going to be more than 100? Go ahead and pause the video now. And welcome back. And you find she's correct. 15 times 7 is 105, which is just greater than 100. All right, next one. A group of friends bought 7 tickets to a dog show for $30 each. How much did they spend on tickets? You may pause the video now. Welcome back. 7 times 3 is 21. There's 1 0, 210. Find each missing exponent. Go ahead and pause the video now. Welcome back. So we had 3 zeros here, 1 there. 3 minus 1 is 2. So that tells me there's going to need to be a 2 there. I have 3 zeros, none over here. 3 minus 0 is 3. So I put the 3 there. There are 4 zeros, none over here. So that's going to have to be a 4. Explain how to determine the number of zeros in the product of 10,000 times 1,000. Go ahead and write your version of the answer. You may pause the video now. Welcome back. And let's see the answer the book gave us. Count the number of zeros in each factor. Remember, each part of a multiplication problem is a factor. To find the number of zeros in the product. If there were 4 and 3, there would be 7 zeros. How can patterns be used to determine products of a number and a power of 10? Go ahead and give me a written form of this answer. I'll see you on the other side. Let me pause the video now. Welcome back. You can use the patterns to multiply mentally and determine the number of zeros in a product to make computations much simpler. It's a long way of saying I can count the zeros so I know how many zeros are in my product. All right, we have now reached the My Homework page, and I will not go further here. You may complete the packet and return it on our Wednesday deliveries, or you may complete the assignment located within our Google Classroom. If you have any questions, please email me at mireland@scigchipschool.net. Bama P.